All right, so we're on Journal 6 today, and we are going to be talking about how trig functions are related to coordinate system, how they can overlay each other. But before we get there, let's start out with our bell work for today. So the bell work here is just saying, like, if you have these 2 points, you have to find the distance between them. So the first point is at the origin, and so the origin's right here at 0, 0, right? So we have that point, and then we have the point 4, 3. So if I go over 4 and then up 3, there's 4, 3. And what it's asking is that you need to find the distance. Let me grab a different color here, but the distance from here to here. Okay? And so to do that, let's just think about these 2 points here. When you connect a point with another point, you form this line, right? But you might already be seeing it as like, well, it kind of reminds me of slope, right? Like if I were to ask you what's the slope here, you guys would say, well, I had to go up 3, right? You had to go up 3 and over 4, And when I do this, do you guys notice that I created a triangle? But not just any triangle, a right triangle. Right? Where the line here represents the hypotenuse of this triangle. So that means if I know 2 sides of this right triangle, couldn't I just go find that hypotenuse if I just use the Pythagorean Theorem, which we learned last time? So that's what we're going to use. We're going to use the Pythagorean Theorem that we created in the last journal to help us out here. So that Pythagorean Theorem was r squared equals x squared plus y squared. And if we plug in our 2 length, our x value and our y value into the formula, we're going to try to solve for our r. So 4 squared plus 3 squared. 4 squared is 16 plus 9. R squared, just bring that r squared down. If I want to get the r squared by itself, I will have to take the square root of both sides. But before I do that, let's add 16 with 9. Which is 25, so r squared. If I want to get r squared by itself, I have to take the square root. These cancel, so r is equal to positive 5. Now we talked about last time, remember when it comes to distance, you want a positive distance. So in this case here, this is our length. So 5 is our hypotenuse. Let me use that in actual color. 5 is our hypotenuse. So we have a distance of 5. I should write the answer here. So distance here is equal to 5, which is our hypotenuse. So today, what we're going to be getting used to doing is being able to take a point and make a triangle on a coordinate system, so that way we can find our trig functions, the sine, cosine, and tangent, using the coordinate system. And I'll show you how in the next slide. Okay, so what I'm going to do is draw myself a coordinate system. So let's take a coordinate system and draw that real quick. And what I'm having us do is, you're always going to be given this point, and most of the time you're given a point on a graph. And so a point, let's call P, has an x and a y value, right? And we learned that if you have a point, you can connect it with the origin, creating a ray or an arrow. But that there is going to help you determine what's your terminal side. So remember, your initial side always starts on the coordinate system, and this here is our terminal side. So our angle is going to be right here, right? This is going to be our theta. I also want to mention, if you remember, when we're moving counterclockwise this way, when we're going from, I guess, right to left, this motion is going to be the positive angle. And so from here, we can form a triangle, a right triangle. And if you look at this angle here, right, this piece right here is representing the x-axis, or the x value on the coordinate. So here it represents the x. And the other side here, the y, or this side here is actually represented by the y, right? Because it tells you the point had to go up this much. It tells you how much the point had to go over to the right, about this much. So that's why that's the x, and this part's the y. But I also want to mention here, whenever you have the angle, so the angle is right here near the origin, the angle that's always adjacent to this theta is going to be the x. And I'll point that out as we go. And the angle that's always opposite of the angle is the y. Now let's talk about this angle right here. So this, we refer it to the hypotenuse if you were looking at it as a triangle. So this here is our hypotenuse, but we've been calling it r. Let me explain why we've been calling it r. Notice how when we're moving on the coordinate system and swinging that terminal angle, it's as if we are forming a circle, right? It's as if I was like, let me grab like a highlighter here. It's as if I'm going from this side here, swinging up. Sorry, that's not a very good circle, but you can see what I mean. That line right there is representing the radius of our circle because of how we turn on a coordinate system. So that's why you'll see me write that as r a lot. So let me take away that circle now. Okay, so from here, let's talk a little bit about how this coordinate system plays onto the trig functions here. So if I were to find my ratios here, let's find our ratios. Sine is going to be pivoting off of this angle. So sine, if you remember, SOHCAHTOA. So I'll write SOHCAHTOA here. So sine is opposite over hypotenuse, or in other words, y, which is the opposite, over the radius. So sine is always going to be y over the radius. Whereas cosine is going to be adjacent, right, over the hypotenuse, or x over the radius. And tangent is going to be the TOA, opposite over adjacent, so y over x. And then we learned the other day that cosecant, secant, and cotangent are just the reciprocal of this. So all I have to do is take these trig functions and flip them on this side here. So this first one here is going to be, let's see, r over y for the reciprocal of sine. And then the reciprocal of cosine is going to be r over x. And then lastly, cotangent is going to be x over y. And so that's all your 6 trig functions on a coordinate system. So I want you guys to get used to seeing sine and cosine as y over r, or as x over r, and so forth. Because we're going to be working a lot on a coordinate system. All right, let's do some practice problems here. So in this problem, I give you a coordinate system, 5, -2, and you have to sketch the graph, and it needs a positive angle when we sketch it, and I'll explain what that means. And then you have to find all those 6 trig values. So first, let's start by graphing by how we've always graphed a point. Okay, we're going to draw a coordinate system, and we're going to graph this point, which is 5, +5. So that's this way, +5. I'll just mark that as 5. And then I have to go down -12. So I'll just say that's -12, and my point is right there. Okay? And so here's the thing. When you connect the dots to make your line, you have to always connect it from the origin, okay? Because the initial side will start here, right? But your terminal angle, or that line that you're going to create, will always be pivoting off the origin, so you want to shoot out from the origin to that point. And so from there, we have our terminal angle, which is great, but we need to draw that positive angle. So to do that, you always start from the initial side and then go counterclockwise until you reach the terminal side. And that's going to be our angle. Actually, let me place the angle here so that way we can use that to figure out our triangle, our trig functions. So remember that I went counterclockwise because it wants the least positive angle, so that's why I would want to go counterclockwise to get a positive angle. So from here, you could form a triangle to show that off, but I just want to mention again, remember, this point here because this was 5, negative 12 as our point, that means that this adjacent side, right, is going to be the value of 5. Whereas this long side here, the opposite side, is going to be the negative 12. So remember, your x's and y's, this is your x and this is your y, is going to be on here. Actually, let me label that. So this side here is 5. This side here is negative 12. The only issue is that we don't know what r is, right? So we can't find all of Trig's function until we know what the hypotenuse is or what r is. So in that case, when we're doing this, we need to go find r. It's like we know what x is, which is 5. We know what y is, which is negative 12. We don't know what r is. So r is using that Pythagorean theorem that we did. Remember, the Pythagorean is r squared equals x squared plus y squared. Or if you're used to this now, you know you have to take the square root of r to get rid of that, and so might as well just write it this way. So what I'm going to do to find r is plug in my x and y, which I already have, right? On the graph you can see them, so I'm plugging them in. And so that's going to be 5 squared plus negative 12 squared. And so if I work this out, 5 squared is going to be 25 plus 144. So if I work this out, 125 plus 144 is 169. Take the square root of that, that's 13. So that means my r is 13. And so if I were to figure out my sine, my cosine, my tangent. So sine is going to be opposite, so this angle opposite and the hypotenuse. Or you can think of it as your x over your y. Remember we learned, sorry, not x, our y over our hypotenuse r. And cosine is our x over r, and tangents are y over x, is what we referred to before. So what we're going to do is get our y, which is negative 12. So that's going to be negative 12 over our radius, which is 13. Our cosines are x first on top, so 5 over 13. And our tangent is going to be negative 12, or y over x, which is 5. And so now if I want the reciprocal, cosecant, secant, and cotangent, that's going to be the reciprocal, so 3 over negative 12, 13 over 5, and 5 over negative 12. And that's it. All right, we're going to practice a few more like this, but I want you to start seeing that sine is related to the y and cosine is related to the x, instead of seeing it as opposite over adjacent. And then tangent's always y over x. So start getting used to seeing it that way, because when we're working with a coordinate system, it makes it easier if you already know that. So we're going to do the same thing here, just more practice. Remember, we're going to sketch it first, so we have to plot that point. So it's negative 24, so I'll say negative 24 is about here. And then negative 7, we'll say about right here. And so our point, we're going to plot. And then we always shoot from the origin to that point. And remember, our terminal side is this angle, where our initial side's here. And so if I were to draw my angle, I need to go counterclockwise to show my angle here. Now from here, remember, this is your x, this is your y, right? So x is equal to negative 24, y is equal to negative 7. We don't know what r is. In other words, if I were to draw this as a right triangle, also you'll notice when I draw my angle here, I always try to form my triangle along that x-axis. So notice how I didn't draw a triangle down here to the y-axis, I drew it to the x-axis. So to find this r here, I'm going to have to use that formula again. So the square root of x squared plus y squared. If I plug things in, 24 negative squared plus negative 7 squared. If I do that in my calculator here, let me go grab a calculator. Feel free to do it in your calculators. But I end up getting, let's see, 625. Take the square root of that. That's 25 there. So my radius here is 25. And so now I have my x, my y's, and my r, so I can figure out my sine, cosine, and tangent. So sine is going to be my y over r, so 7 over 25, negative 7 over 25. Cosine is going to be negative 24 over 25, the x over the hypotenuse. And tangent is your y over x, so that's going to be negative 24 over negative 7. But here's the thing, that's two negatives on this fraction. So remember, fractions are just division. So like negative 24 divided by a negative 7 is going to be a positive number because there's two negatives. So this is really positive 24 over 7. Okay, so once you have your ratios, let's go find the reciprocal. So if we were to flip, this would be 25 over negative 7. 25 over negative 24, and 7 over 24. And that's it. So sketching the graph, you're just going to show, You're just going to show the point, make your terminal angle, so this angle or arrow here, and then show that angle. All right, let's try two more problems here. All right, this problem is really interesting because one of them is going to be a 0, right? Our x here is a 0, and our y is going to be a 2. So let's go ahead and draw our coordinate point.
Grossman, please head to the science parking lot to meet your ride. Julian Grossman, head to the science parking lot to meet your ride. Thank you.
So as you can see, I've plotted my point because 0 for x is right here, and I have to go up 2 since that's y. And so that's right here. And so when I draw that point from here to here, I noticed that, I don't think I can draw a triangle when the array is pointing up, right? Like how do I draw this triangle? It's a little bit tougher. So let's think about it for a sec. Do we really need a triangle to represent, to know what our hypotenuse is or what our radius is? Because let's think about it. The radius is really the array here, right? If you go back to the other problems, when you were looking at the terminal side or the array, the arrow, that represented your hypotenuse or the r, right? So looking at this arrow here, what is the length? Well, it goes up to 2. So this here has to be a length of 2. R must be 2. So our x here is 0, our y is 2, but r, I guess, is also 2. But if you don't trust yourself, you can still use that formula, right? R equals the square root of x squared plus y squared. If you plug in your x value and your y value, so 0 squared plus 2 squared, right? So 0 squared is 0, 2 squared is 4. So this is really just a 4 underneath. And then 4 squared, oh, that's just 2. Well and behold, the r here is also 2, right? That we saw that on the graph here, this ray or this arrow has a length of 2. So now what we're going to do here, we are going to find our trig functions because we have all of them. So let's take a look here. If I were to set them up, let me grab my pen here. So we have sine, which is going to be y over r, which is going to be 2 over 2, which can be reduced down to 1, right? 2 divided by 2 is just 1. Cosine is going to be x over r, which is going to be 0 over 2. 0 divided by 2 is just 0. When 0 is on top, you get 0. Tangent is going to be our y, which is 2 over x, which is 0. Oh, but hang on. That is a 0 on the bottom. Anytime you have 0 on the bottom, it's what we call undefined. You can't divide by 0 in the bottom. And then let's take a look at our cosecant, secant, and cotangent. So our cosecant is going to be 2 over 2. Remember, if we were to flip this, still be 2 over 2, which would still be 1. Our secant is going to now be, if I flip this ratio, it's going to be 2 over 0. Oh no, 2 over 0, 0 on the bottom means it's undefined. So we actually have something undefined for secant now. And then our cotangent is going to be flipping this ratio here, 2 over 0, to being 0 over 2, which now means that this 0 being on top is going to just lead to a 0. And so that's all our trig functions here, all 6 of them. Okay, and I guess I didn't draw my angle here. So my angle, remember that our initial side's always here, and so it's shooting up. So this is a 90-degree angle, it looks like, if you're going from this to this side here. That's 90 degrees. But we just have to label where that angle would be. We don't have to tell what it is. All right, last slide here. Okay, so last problem that I'm going to do from the homework. And remember, this is from chapter 14.3. So this time I'm going to be giving you a problem where there's a root or a rational number. So what I'm going to do first is just plot it, like we always do. Sketch the graph. And so we have a -1, which would be this way. A square root of 3 is about a little bit over 1 if you put that in the calculator. So maybe like down here, we'll just say is the square root of 3. We'll plot the point here. And remember, we shoot from the origin. And so now I have my line. And then I am always starting with my terminal side, and I'm spinning towards that terminal. I always start from my initial side and then go counterclockwise to my terminal side. So that's going to be my angle. And so you might be noticing that I'm no longer making a triangle out of my coordinate system because I don't have to. I just have to recognize what is my x, and in this case, it's my -1. My y is going to be the square root of 3. Y is the square root of 3. And now I need to find r, and so r, I could use that formula, the square root of x squared. So x squared is going to be -1 squared, and the square root of 3 squared. But here's the thing, when we take the square root, or the square of -1, that's just going to be +1, right? Because -1 times -1 is +1. When we take a square root of 3 and square it, well, the square and the root will cancel, bringing out just the 3. Because if you think about it, the square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is just 3.
At this time, students, you should all be out of the building or with a teacher at this time. If you need to be waiting for a ride, you may wait up front in the vestibule or outside. Thank you and have a great evening.
Okay, sorry about those announcements. So what I did was I took the square of both numbers, added them, got 4, took the square root of 4, which is 2. So our radius here is 2, and so now we can set up our trig functions here. So our sine is our y over r, so square root of 3 over 2. Our cosine is going to be x, which is -1 over r, which is 2, so -1/2. And tangent is y over x, so square root of 3 over -1, that's just going to be negative square root of 3, because if you divide anything by 1, you get itself, but because it's a -1, it's a negative square root of 3. Okay, now that we have the ratios, we're going to find the reciprocal. So if I were to flip this, this would be 2 over the square root of 3. And then this would be secant -2 over 1, which is just -2, right, if you were to divide that number. And then tangent, or not tangent, sorry, cotangent is going to be -1 over the square root of 3. Now, here's the thing. There's a problem. You see how the bottom here has a root? Actually, let me just highlight that. Has a root here. Well, here's the thing. You cannot have, write that here in red. Get my red pen. So, you cannot have roots in the denominator. The reason why is that you don't want to divide by a rational function because it's very difficult to do that. So you generally want to get rid of that rational function in the bottom, or rational number in the bottom. So what we have to do is we have to multiply the top, the bottom and the top, but mainly the bottom, by the same root. So we look at whatever's in the denominator, see what root that is, and multiply the bottom by that root and the top. So I'd have to multiply the bottom by the square root of 3 since that's the same, and then I have to multiply the top by that, because anything you do to the bottom, you have to do it to the top if you don't want to change the actual fraction. So this would be 2 over the square root of 3. When you multiply the square root of 3 with the square root of 3, you get the square root of 9. Take the square root of 9, and that's actually just 3. So just as a shortcut here, anytime you have the two of the same square roots, they cancel each other, and so just bringing the number outside of the root. So they're both 3, so I'm just going to write a 3 here. And notice how now there's no root in the bottom, so this here is my answer. Box in the ones that were my answers. And so the bottom one here that I still haven't done, I'm going to multiply the bottom by the square root of 3 to get rid of it. So multiplying the bottom by the square root of 3 basically cancels out that root, and so now it's a positive 3 in the bottom, but negative 1 times the square root of 3 is just a negative square root of 3. But that's okay for the root to be on the top. And so that is all my 6 trig functions. So, yep, once you notice that there's no more roots in the bottom, you know that you have, you're good. What this process is called when you're trying to get the root from the bottom and multiplying by the same root, this is what we call rationalizing the denominator. All right, that's it for today. So problems that are assigned in this, recommended for this journal is problem from 14.3, problems through 1 through 20, I believe. All right, that's it for today.